to be here today to talk about what feels like a generational build-out for the American industrial base, which is really a $7 trillion investment opportunity that will be driven over the next 5 years. If we go back, $7 trillion is a really large number. That's the amount of investment that has been committed to AI and data center infrastructure. To just give that dimensions, that's 54 times the cost of the build-out of the interstate system in the US. 250 times the cost of putting a man on the moon as part of the Apollo program. And that's $15,000 to $20,000 of 20,000 Boeing 787 airplanes that you can buy for that amount. So if you're doing all of that just within the span of 5 years, that's not going to be an easy feat. And so I'm excited to invite our panelists here today to talk about how will we actually achieve it and what is the role that automation will play. We have a fantastic group of people, starting with Scott Armul from Vertiv, Ujjwal Kumar from Siemens. We have John Bubnikovich from ABB Robotics, and then Stefan Nusser from Google Intrinsic. Please welcome me in inviting them on the stage. So before we jump in, maybe we'll start with a quick round of introductions and also talk about what excites you the most about the data center build-out. Stefan?
So hello, everyone. My name is Stefan. I'm Chief Product and Commercial Officer at Intrinsic. Intrinsic's part of Google. We offer a software platform for AI and robotics. We are very excited to be pushing into tasks that have traditionally been either too inflexible or too hard to automate, right? This is where we see AI making the big contribution. When we look at the data center space, there is plenty of these tasks, right? If you think about, for example, cables, automating anything to do with cables, plugging them on a board, connecting so the chips and the units of an AI server, these tasks are being done by humans. If you want to build to the extent of 50 times the interstate system, right? We're going to be plugging a lot of cables, and being able to automate that task would be a big step. Similarly, as we look at these components, the variations are growing, right? There's many different AI servers. They're very complex machines. So as we're automating the building process, we'd like to try many different variations. We'd like to put together different combinations of racks. So there's sort of this combinatorial explosion of variations. And again, having a flexible form of automation, which is what AI allows us to do, is also helpful. So those are the things, hard problems that we can't automate today, and adding flexibility to the things that we can automate today. Those are the two things that get me excited about this space.
Awesome. John, from ABB's vantage.
Yeah, good afternoon. I'm John Bubnikovich. I'm the president and U.S. country leader for ABB Robotics. And what's really exciting is this is a transformational time. And where automation was used in the past for optimization, it's almost imperative it's going to be used with the scale of this data center buildup. So it has to be transformational. There's some applications that are translatable that we can do and we have solved today, and then others that more unstructured and in dynamic environments that AI will help us solve in the future.
Exciting times. Ujjwal.
Yeah, hi. I'm Ujjwal Kumar, president of Siemens Automation Americas. What really excites me about this, what is going on in the data center space, is we are creating automation in a post-software world. In every other sector, whether it is life sciences or aero or automotive, looks like we had created our operations in one way, and then we brought digitization, robotics, all those things later on. Here we have all those tools to automate our processes end to end. So it's very exciting to bring in the latest in the technology world to create this exciting new space for us.
Amazing. And Scott?
I'm Scott Armul, Chief Product and Technology Officer for Vertiv. We basically do power and cooling and infrastructure solutions for the data center builds themselves. What's so exciting about this is maybe a lot of things, but the scale Ani talked about, we're talking about 140 to 150 gigawatts or more deployed over the next 5 years. The speed at which we are having to roll this out in order to keep up with an ever-increasing demand. The scale of the actual facilities themselves, we're talking about data centers that are 200 megawatts, 500 megawatts, gigawatt campuses that are going up across the US and globally. And we're doing this on a technology cycle now that is effectively a brand new, complete technology overhaul from a GPU perspective inside of 12 months. So speed, scale, and technology cycle has just been transformational, which is a really fun time to be in the middle of trying to figure out how to build all of these things.
So, we calibrated earlier to the amount of capital that's being invested is also 250 times the Apollo space program. So we're talking about sending people to the moon and back 250 times. So Scott, Vertiv sits very close to the data center ecosystem, the customers. How do you calibrate on how much of this demand signal is real? Like, where are their bottlenecks? How much of this will actually get built out? Would love to get sort of your take.
It's fascinating. We throw out large numbers, and I think we've become desensitized to them as humans. Like, I often talk, like 150 gigawatts, what I just rattled off is effectively what the entire install base of US data centers was 10 to 15 years ago. And we're talking about deploying 10x that over a 5-year planning horizon. Just fascinating. We're very close to customers in the build activity of kind of the base infrastructure of data centers. I would say the demand is real. The demand is not, like the supply cannot keep up with the demand. But there are a lot of constraints in the industry. Power availability, skilled labor and skilled trades, the scale at which we've been talking about trying to build, the locations some of these data centers and facilities are going into, begs for rethinking the way in which we do things. And one of the missions we've been on at Vertiv and collaborating across the ecosystem is trying to figure out a journey to get data centers to be produced in more of a prefabricated, more of a systemic fashion that allows not every single one to have to be a snowflake. To not every deployment has to be this unique type of a deployment model, but to bring back more of a system design approach, more of a standardized design approach that we can start to put some thinking towards prefabrication, skidding, system designed infrastructure, and deploy at the scale that's going to be required, because without it, we will barely be able to scratch the surface of what the market actually demands and needs. Yeah,
these data centers can't be unicorns each time we build them. So maybe John, coming to you, you talked about robotics moving from an optimization to a transformation framework. What type of problems are you seeing? Customers wanting you to solve? Where is ABB Robotics playing a role? Is it construction? Is it fabrication? Installation?
Yeah, we look at it across the whole value chain. So Scott touched on it really well when he talked about the scale at which these data centers need to be built. And if you think about the shift from your traditional construction mindset of building things on site to more of an industrial product or manufacturing approach where you build modules and bring the modules on site kind of and let's call it a Lego block format. That's what needs to happen. That's the only way these data centers, when you look at the numbers, they're staggering. I mean, 1,000 to 1,500 by 2030, and these data centers cost anywhere from $10 million to $10 billion. So there needs to be some kind of standardization approach where you can scale in a way. And that's really looking at a shift from on-site construction, a one-off every time, to more of a repeatable modular format. Now, you can do that one of two ways. You can have a regional factory that you produce these modules at and bring them on-site, or you could have on-site automation. Now, there's some challenges with doing it on-site. I think we'll see that in the future, but with calibration and things like that, there are some challenges with actually having the automation on-site. But at the end of the day, they're going to have to rethink how the construction and building of these data centers is done and look at it more innovatively and not kind of take the traditional approach of just building on site.
And maybe, Stefan, coming to you, Scott and John both talked about standardization, but it feels like there is a dual problem of standardization yet flexibility, because designs are changing and the requirements are changing. So how have you approached that with your products?
With essentially a software-based solution, right? I think that to me is one of the biggest trends I'm seeing here in the industry. I've been around robots for 15 years, and it's a family of technologies that are time-tested and well established. But I've started my life as a software engineer, and it was always striking me as a real gap between how software engineers work and how the automation community works for good reasons, right? And I think that gap is closing. And so what we're seeing today is automation that's being built on software and that's therefore flexible and can be reconfigured to do different things. So to give you an example, Intrinsic is running a public challenge, right? It's called the AI for Industry Challenge, and we make freely available for anyone who wants to participate a set of, almost think of a sandbox, a software sandbox. It builds on a public API layer called ROS, the robot operating system that anyone can access, right? It's open source, you can build on it, and it essentially includes artifacts like the CAD model of a motherboard, a picture of the cables, and there is a challenge task. And the task is to control a robot arm, to take the cable, plug it into the motherboard, plug it into an extension card. And we had over 5,000 people sign up for that challenge, right? And those 5,000 people, they're all able to work in software, they're all able to use AI, use simulators to train models and solve that problem, right? And what that means to me is that going forward, increasingly, we're gonna see a software-driven architecture, and that's gonna give us that ability to combine both standardization with flexibility.
That's interesting. I think, Ujjwal, you also referenced sort of you're building now the era of software-defined architectures, and not only do we have to build these data centers, we have to operate them, we have to maintain them. So from your sort of Siemens vantage point, what do you see that's new in this sort of software era that the industries that automated previously could not take advantage of?
Sure. So these data centers, the size and where they are being installed, we see that they are going to these autonomous operations from day one, which has huge implications not just on how we are installing those things. And you know, a lot of our data centers right now, they're still shell because they don't have the NVIDIA chip yet. And once they are all in, it'll have huge implications for John's business on autonomous maintenance of those servers and moving cables around and stuff. One of the things which is mind-boggling is more than what you're talking about, just the size. It is the speed with which new technologies are coming into every aspect of data center value chain, from power management to cooling to automation or your digital infrastructure. We were all optimizing towards this AC-based power management. This year, we already started working on DC. Completely changes the software layer, how you are looking at safety and everything. On cooling, we moved from air to liquid-based, and you know, some of us are engaged on that multi-phase flow cooling already for this next generation of NVIDIA chips, or automation going towards autonomous. Like across the value chain, it's this huge scale, and the speed of innovation is mind-boggling.
That's really interesting. And you know, Scott, you talked about designing with a systems engineering approach. How are you doing that when, to Ujjwal's point, technology is inflecting so quickly?
I think it goes together very appropriately in that the speed of technology and maybe the architecture shifts that are happening at the data center level are driving a need for systems design, because individual components and individual standalone approaches to data center design won't unlock the performance, the capability, the precision that's needed for next generation AI-based training and AI factory facilities. You touched on liquid cooling, which I think is right on. The powertrain of a data center facility is moving from a traditional low voltage AC architecture to one of potentially 800 volt DC within the white space, or potentially even a centralized DC power architecture. The precision required for liquid cooling starts to resemble more of a precision process facility. We're talking about GPU racks that are current state 140 kilowatts. Tomorrow they will be 240 kilowatts in a single rack, and we have line of sight to megawatt racks That density is astounding, but maybe more importantly, to cool a chip in that fashion requires liquid cooling direct to chip, a very precisely monitored and managed technical water loop that has maybe 1 to 2 seconds of potential out of bounds on the performance parameters before you're either throttling GPU performance or you're taking a site down. And that is a level of precision and a level of control that data centers, quite frankly, didn't have to think about 5 years ago. And we think about the entire facility needs to be orchestrated and operated in order to unlock and enable that performance. 10 years ago in an air-based data center, you wouldn't even connect the thermal system to backup power. You had 20 to 30 minutes of potential thermal inertia and ride-through to be able to manage a switch over to generators. Like you said, liquid cooling now, you have 1 to 2 seconds.
Wow.
It's a different fundamental thought process.
And maybe just sticking with you, are these performance parameters driving customer decisions, or is it time to tokens? Because there are shortages and lead times to also factor in.
I do think it's all of the above, and we talk about this concept of tokenomics, and tokens as the unit of compute or the output for data center performance now. A lot of the performance is in terms of economics, kind of your tokens per dollar, but it's also things like tokens per kilowatt or tokens per megawatt, your tokens per second per megawatt, the actual performance based on the envelope of the power you have available in a facility. So much of the focus of infrastructure design and getting back to why it's important to think about this as an entire system, there are performance and efficiency benefits at each of the seams between subsystems that if you can unlock, we can create a different level of performance capability at the IT itself that helps unlock some of the scarce resources we've been talking about. Power to the facility, time to interconnect, kind of scarce resources as it relates to building these larger facilities. It's a fundamental like necessary paradigm for data centers to solve to unlock and enable that performance level.
And maybe, John, so if we were trying to address some of these bottlenecks, whether it's power, so power equipment, electrical equipment, these are sectors, even construction, that haven't automated or used robots as much as automotive or consumer electronics has before. Is it a design problem, or is it a robot capability problem? And which of them do you think sort of moves the needle the most?
Yeah, so maybe I'll start with, I think, the first step is now it's a changing and dynamic environment. And when you look at the simulation tools out there today, and you can simulate using high fidelity and synthetic data, it really reduces some of that risk initially and allows you to get faster to market. Now, to your question relative to the application, there are, of course, the competence built in these by other industries in some of these application spaces, like welding and joining, material handling, assembly, are all translatable. To Stefan's point, of course, that next level of automation will come with autonomous, versatile robots, where robots will be able to work in a more unstructured environment and perform things like cable management processes that they haven't been able to wasn't able to be done before. And AI is unlocking a lot of that potential. Now, when I think about construction and maybe a barrier to entry, I don't think it's more technical. I think it's more on the operations side, honestly. When you look at, if you're a construction company, you have a very compressed time frame to get this done. You don't have a lot of time to train automation engineers on how to use automation equipment. So I think when you start to think about it from a construction standpoint, it has to be a fundamental shift. And that means retraining or training of the workforce and preparing some of these construction companies with the right tools to be able to adopt automation to accelerate project timelines.
And maybe building off of that, Stefan, like what tasks do you think are going to be solvable with AI and the types of platforms you're building today? And do you think the economics of automating those tasks is also changed?
Yeah, actually, the economics is, I think, the most interesting aspect. If you look at the tasks that are involved in the fabrication process, let's say towards the end of the fabrication process, so putting together a server, cabling it up, putting AI servers into racks and cabling up the racks, most of those tasks actually are automatable today with traditional technologies. It just takes a lot of time and a lot of investment to get them automated. So the value of flexibility is that you're not creating single-purpose automation. Right? That is a big, very fundamental change. If you can create automation that is easy to reconfigure, then you don't have to amortize it over the lifespan of your product. Right? The lifespan of a server is, let's say, a year and a half last year, a year this year, maybe 9 months next year. Right? It's shrinking. This is accelerating. It doesn't make sense to put traditional automation in place for something that runs for only 1 year, because traditional automation is single purpose, and after that 1 year, you have to throw it away. Now, if you have automation that's reconfigurable, then you can software configure it for the next generation of the product and the next generation. At the Intrinsic booth, we're showcasing the Intrinsic Intelligence Cell that is essentially a software configurable multi-purpose manufacturing cell for electronics that runs our operating system. And the point of that demonstration is to show how you can have automation that can outlive the lifespan of your products, and that can be creating value for you over several generations of the product simply by you reconfiguring it as the servers evolve, as the characteristics of the machine, the cables, the interfaces, as all these things change. You essentially reprogram your automation, and then you're good to go again.
And you said reconfigurability is sort of a key advantage. People often talk about data being a bottleneck in robotics. Like, how much data is needed to be able to reconfigure this system? Is it a plug and play if cable design changes? Like, how much more data needs to be added?
So data is definitely key. Data comes in different flavors, right? Data can be a CAD model. The nice thing about electronics manufacturing is you have CAD models for almost anything, right? So with a CAD model in hand, you can do a lot of things. You can also generalize from a number of CAD models with a foundation model. For example, we've done this with a vision model that is used to detect components. You train it on a population of CAD models, and then you're able to just give it a CAD model, and it will recognize a new part that it has never seen before. Right? So there's a level of generalization here happening in these technologies, thanks to the foundation model technology, that allows us to be generalized within a population, let's say DIMM sticks or boards. And those models are available today. In other situations, you will need data from the concrete task, right? So with so-called reinforcement learning approaches, you do need data sets that you can then generate yourself, right? So where we are sort of looking at on the R&D side is to be generating that data easily with cooperation from the operator, and then that is used to refine a generalized model so that it works for a specific task, right? So there's different flavors of data here. Some of it is more generalized, some of it is very task-specific. That's going to have to be created and collected in the field.
And Ujjwal, coming to you, I think this data question is not just a bottleneck for the robot in sort of post-estimation and things. I imagine a lot of the data center operators are generating tremendous amount of data. Do you see them fully harnessing the value from the data set yet, or are digital twins, just virtualizations? Are we actually making decisions and executing on recommendations?
No, absolutely. We do see digital twin being played during design and operationalized a lot more than any other industry we have seen in before, primarily because there is a lot of pressure on quick deployment, and digital twin helps with that. But there is one other data point which Wall Street doesn't realize yet. To Scott's point on how much it used to cost to get those inferences, we were charging $20,000 per billion tokens 4 years back. Today it is less than $70 per billion tokens, which is we have not seen that kind of productivity or fundamental change in economics, to your point, in any other industry before. Yeah. That also means now our data center customers, they need to squeeze out 20 times more inference from that same footprint, while having that very narrow, precision is the right word, precise cooling performance, which is, by the way, between if I remember it correctly, 44 degrees C to 46.5. Within that 2.5 degrees C, if you go off range, your performance nosedives. You have to run it while your economics has gone 20x lower than 4 years back. So all the tools we have on digital twin, software-based automation, software-based execution, we have to bring all those tools to run this in the most productive way possible.
And given each of these sites will now have multiple vendors for different systems involved, do you think there needs to be some standards, whether it's data standards, interoperability, that needs to be established to, again, make this sort of happen at speed?
So I think players like Siemens, they are able to grow so quickly in the data center space is because it is inherently open architecture and with a focus on interoperability. So all the players you see there who are able to connect with customers quickly and pull in all kinds of vendors, because no one vendor has the whole technology stack, are the ones who are more of a platform play and with interoperability built into their architecture.
Makes sense. And Scott, maybe coming to you as well, you are feeding into the data center value stream, but you're also building components. In your own build process, what type of these technologies are you integrating? Is it digital twins, automation?
Exactly that, and we're in an interesting spot because we're building the infrastructure that's needed to unlock the intelligence to really make automation kind of mainstream and possible here. We're also a manufacturer, so we're building chillers and assembling UPS systems and delivering secondary fluid networks and hot aisle containment. We're building the actual physical manufacturing of the components and the physical data centers themselves. So even on a production line, how we figure out how to better assemble chillers, how we move material, how we manage and leverage visualization and robotics is part and parcel to what we do. And quite frankly, we have a long way to go. This is an industry that hasn't had to automate to that level because of the technology cycles and because of the scale. There's a forcing function there now. I think about services and commissioning and field service personnel. We're talking about massive commissioning sites. We're talking about electrical service personnel that are now operating above the safe low voltage environment, and things that will be needed to not only automate but help engender safety and faster throughputs and other things when we're starting to talk about a site. But I think I really like and appreciate the digital twin model, and more of the physics-based modeling associated with the infrastructure itself has to become a core part of how we actually design, deploy, and deliver data centers, because we don't have the time to fail in the physical world at scale. And at the end of the day, we're still moving chillers with cranes. We're putting things on the roof. We're moving massive physical infrastructure. So if we can design and orchestrate in a digital simulated environment before we ever have to assemble a prototype or before we ever start moving equipment to a site, that's the key to unlocking these extremely aggressive deployment cycles and ensuring that we can figure out ways to actually harness the throughput that's needed for the scale here.
Makes sense. And maybe, John, you brought this point up as well around construction being constrained by lack of, they don't have time to train automation engineers. It's almost like a chicken and egg issue there. What lessons should this industry pick up from other sectors that have automated successfully at scale? Like, what does it actually take to make this part of your operating system?
Yeah, I think so. Certainly there's some lessons to be learned by, even if you look at where automotive was 30 years ago, right? But now the interesting thing is robots are and automation is a lot easier to deploy, and it's a lot easier to use and maintain, right? So that's a huge factor, where 30 years ago you did need an army of engineers and really deep pockets. Now automation has came such a long way that you see even a lot of small to medium-sized enterprises using it because of the ease of use. So that's going to be a critical factor. To Stefan's point about the data, and with the kind of changing landscape and the products evolving very quickly, that data is going to be super important for these global AI foundational models, because that will allow you to make adjustments without having to build another data set. So I think that's going to be a really critical thing, is maintaining or ensuring that the data is categorized in the right way so it can be translatable to a new product through this global, foundational AI model.
And maybe staying with you, there's a lot of thematic conversation around moving to a foundation model approach to controlling robots. What part of the integration workflow that historically was so key to automation and robotics gets disrupted, but still perhaps what part of it stays around?
Yeah, I think if you start to look at disruption in the automation or robotics space, I mean, it could really be said that, when you look at the controls architecture, typically for a robot, I saw Stefan look at me there, because the controls architecture for a robot, where before it was, of course, your motion path planner was the secret sauce. Now when you look at how robots are being used in some of these application spaces through EGM, I think that's something where robot companies need to build and adjust like ABB. We're really looking at how do we have an AI-enabled robot? And what does that mean? Do you need all the things that you traditionally needed with a robot cell in a fixed environment, or do you have to build the equipment differently to make it more AI-enabled so you can easily integrate with some of these foundation models in these AI companies? So that's going to be a critical shift in the industry that we'll see over the next couple of years.
Stefan, anything to add?
I think that's exactly what we're going to see there is we'll see this evolve into, I think, a layered system, right? Where you have a core, if you want, that contains your safety, that contains sort of the aspects of the control system that relate to the hardware, the limits of the hardware that you don't want to exceed. And that core will remain a sort of a protective layer around the hardware. But on top of that, you're going to see different AI-based approaches. This could be trained models. This could be, prompted and generated code, very dynamic, right? So you'll see the layers above change and become more dynamic, and that's going to enable those sort of more flexible, variable approaches that we've been talking about. But at the same time, you still very much depend on sort of the robotics companies, and I guess I'm looking at you here, John, right? Like maintaining that shell, that core, yep, right? That encapsulates the capabilities, the safety, and ensures that what sort of the generated and the AI layer on top does is within the parameters, within the envelope of what we're looking for.
Makes a lot of sense. I know we're coming up on the last few minutes here, so I wanted to just throw a question to all of you. If you had now the power to change something that allows us to actually do our 250 Apollo missions in the next 5 years, what would be a thing that you think the ecosystem needs to invest in to accelerate the data center build out? Maybe Scott, starting with you.
Oh, you'll start with me. I think we hit on the central theme here, and maybe moving towards more of a prefabricated, solutions-oriented type of a design, I think, is key and paramount. But I also maybe want to highlight that we tend to talk in terms of the large scale and the mega data centers and the hyperscale facilities that underpin a lot of the training and the model development. Building on that last point, very fascinating to me that there will be different shapes and sizes for inference and engagement with the model, to where it's everything from a two-rack deployment in a manufacturing facility to, edge is going to be cool again. And I know we've talked about this over and over again, but we will have such a wide spectrum of the things that will need to happen. In terms of a magic wand, I don't have any hope or ambition that the pace of IT development is going to slow down. So really, I think what I'm looking for as sort of the central infrastructure provider in the industry is to continue to build out an ecosystem where we have an end goal in mind, as opposed to splintering into a million different objectives and strands and other things. I think that's the nature of the industry that we operate in, but moving towards maybe back to focusing on the performance and what we're unlocking from a tokenomics and a power usage and an effectiveness perspective, I think is really maybe my hope for an objective for the industry.
So, Ujjwal?
I'm expecting the data center world to move towards a lot more modularization. So the data center itself will get smaller in size, and I see a couple of mega trends driving it. One is we have issue in grid stabilization wherever we set it up. We have water shortages. You have to take all that data through these massive cable network out of that area, which is a massive challenge. And on top of that, several of the countries, say in Europe, when they are looking at their data center, nobody is trusting anybody else to have this data center. Everybody wants to have their own country-based data centers. And we'll go with lot more modular data center designs, in my view.
Makes sense. John?
Yeah, I think modularity and standardization equals scale. And when you start to look at, you're not going to slow down the speed of innovation, especially on the server side. So there's it's highly unlikely we're going to have like a scalable standard for server racks. But the ability for robotics to be more adaptable, I think, is going to be critical. And handle the different variations in a way that it is more autonomous and can recognize, hey, this is what I need to do based on this variation using an AI foundational model. So I think that's going to be what we'll see in the next couple years is autonomous, versatile robots.
Exciting.
Yeah, I hear both. I'm going to focus on the fabrication part of the sort of the equation here. I hear both Ujjwal and myself making the case for a more software-defined approach. I hear Scott very respectfully asking for robustness, and that's many times where software sort of relative to traditional automation technologies falls a little short. And so what I would like to see is a more matrixed type of manufacturing, right? Less linear. Most manufacturing today happens in a line. In a line, robustness is critical. If you have 20 steps that are happening in a line and one step fails, all the other ones go down, right? If you have a matrix that is made out of more multi-purpose manufacturing nodes, right? Think a little bit like a data center. In a data center, if a server goes down, it's not a problem, right? Servers go down all the time, right? There's someone who goes through and just pulls them out of the rack and plugs in new ones. No one notices anything. I'd love for manufacturing to be that way. I actually think it's not, the right question isn't to say, hey, when will software be 100%? The right question is to say, well, how can we pull apart this line and turn it into a matrix so that if one of the nodes fails, there's still a couple of parallel nodes that can do the same thing so that we don't notice, right? So that's what I'd like to see, a fully matrixed manufacturing capability that's a little bit like the data center that powers a cloud, right?
So we are breaking the Henry Ford mold. And
Yes, we're totally doing that.
Yeah. We do have a few minutes left for any audience questions, so we can perhaps take a couple if there are. Could you wait a second? They're getting you a microphone.
I'm coming from the Canadian market where there's a ton of interest in data centers, but on top of some of the technology problems that we've been discussing today, a lot of the pushback that manufacturers are facing is community sentiment of not necessarily wanting data centers in these areas. And so I'm interested if, one, you think that that's a problem that needs to be addressed, given that we're moving in a direction where they're going to have them whether they want them or not. And two, if you think it is something that needs to be addressed, what can be done in order to build a little bit more community trust in these projects? Thank you.
I'm happy to.
Yeah, Scott.
Certainly an important issue, and interestingly, I think actually community sentiment, the not in my backyard movement, call it what you want to call it, is probably becoming just as significant as power availability and interconnects in certain municipalities and certain markets. I think very simplistically, we need to do a better collective job in the US and abroad of just being very deliberate with zoning and not having data centers be butting up against people's backyards, literally and figuratively. But there's also a lot in the industry, I think, that needs to be level set on in terms of, one, the notion, like, data centers are mission critical and kind of national critical assets. The internet doesn't work, your apps don't work, mission critical business processes don't work without the underpinnings of data centers in the cloud and everything else. And I think that needs to be fundamentally understood from the communities that are often pushing back on these things. But then at the same time, what are the reasons why, and getting a kind of a grassroots educational level on things like water consumption and using closed loop cooling systems that don't actually consume water, and making sure folks understand that. Power availability, and understanding that even in environments where you can bring your own power for a generation asset, you can do it in a fashion that is just as, if not more efficient than the grid itself. Understanding like what we're unlocking and enabling through the data center builds and the technologies, I think is key. And then I do think the industry itself is coming through a bit of an awakening in terms of we can't operate in a clandestine environment through NDAs with communities. There needs to be more of a proactive design with and design for communities, as opposed to having it be this brute of a physical asset that's being forced upon communities. It is a necessary part of our society, and I think it's going to unlock tremendous potential, and there's just a lot of room for aligning on education of what the facts really truly are, and then understanding how we can actually do this better together.
Well said.
Hi, I'm the robotics lead at HIT Contracting. We build a few data centers, and we're doing, we're a general contractor. We have a big role to play in this ecosystem. We're doing everything we can to drive adoption on our job sites. One of the challenges that we see is just how fragmented this industry is. Hundreds of thousands of subcontractors. Let's say you have a really good robotic solution. Trying to get that adopted at a scale that can really make an impact in the industry is really tough. So I'm wondering if you all have any thoughts on, the fragmented ecosystem in the construction space, even around data centers, and how, let's say a robotics company has a great solution. What's a winning strategy for getting it out on more and more job sites?
John?
Yeah, I think so. That's great. I think your company's taking a step in the right direction relative to adoption of automation, and I'm sure it's been a journey where you've had to educate a lot of the workforce on how to use automation and how to work differently. Now, I think there does need to be, when you look at the fragmentation across the industry, I think there's some things that you can do to support or help that. Maybe having a committee to determine, to drive education and training for automation solutions, because I don't know that companies are all going to adopt the same processes or the same solutions, right? But I think if you can educate the industry on this is how automation can benefit your business in a way where they're willing to make the investment in training, in products, and support of the workforce, there's a lot of benefit relative to even increasing kind of one's skill set to be able to become, to have them more marketable. So I think, it comes down to education and training across the industry. But the fragmentation thing, there's a lot of different size companies, working in this space that it's going to be hard for a consolidation to happen, at least initially. Maybe down the road there's a consolidation opportunity, but initially I think it comes down to this education of the workforce and of companies on the benefits that they're going to get from using automation.
Yeah. Awesome.
Okay.
No, we
One more.
Anything to add?
I think we are over time.
Hi, everyone. I'm Jesse. I'm working on a robotics startup right now. And what I'd really love to hear from you guys is, you've all talked a lot about how important flexibility in manufacturing is and flexibility in your different workflows. I'm curious, when it comes to a data center, when you're working on a specific problem, where is it the part that you've tried to automate that's been the hardest for you to actually make stick? The ones that you've tried before, I don't know, maybe it's assembling something, maybe it's using tools, but if you could walk me through what is the part that you've tried and is just the hardest, that would help us a lot. Thank you.
So, I'll be happy to go first here, right? So off the top of my mind, I would say cable harnesses, gluing, moving components into test stations, moving components into racks, and then again cabling up, cabling down, right? Those steps. If you look at the process today, this is where most of the manual work is. Right?
Yeah, I would say the same. You mentioned it earlier. That absolutely, I think cable management and cable insertions, one of those things that is a really challenging area. Not that it can't be done, but it's very difficult because of the flexibility of the cable and how you're managing it, managing the manipulation process.
Like I've seen the maintenance of these data centers in an autonomous way is a huge problem still to be solved.
Yes.
People are using all kinds of AI algorithm, robotics for handling those cables.
I would say +1 on cabling, and that's true at the product level, and that's true at the site level. The other aspect I tend to lean into is commissioning. And commissioning on site, the test and turn up of a site is an extremely manual process today, even if a lot of the subsystems are kind of hardware in the loop and testing. But the more we can start to think of data center facilities themselves as the system, commissioning can then start to be thought of in terms of end-of-line testing for a product.
Excellent. So with that, please join me in thanking the panel for sharing their perspectives. I think it was an engaging conversation.
Thank you.
Thank you, everyone.